All right, so now that we know what rational numbers are, let's do a little practice and some examples. Number one, let's have, and go ahead and put these in your notes as well. Let's have 5. Number 2, pi. Number 3, 2.3333. Number 4, square root of 7. Number 5, square root of 16. Okay? Oh, let's do one more. And number 6, 8/9. Okay, so let's go back to what we know about rational numbers. First of all, we know that all whole numbers are rational numbers, and so this is going to be, 5 will be a rational number. Okay, we know that pi is not a rational number because it's one of those numbers that keeps repeating. It'll go on and on and on and on and on and on without terminating, and so therefore we know that this is irrational. Now I'm going to add one more here. All right, so I'm going to do that one there as well. All right, 2.33333. That's a repeating decimal, and we just learned that all repeating decimals are rational numbers. Okay? Square root of 7. Remember the square root, and you can check it on your calculator if you want to. Just take your clear. I'm going to take 7, square root of 7, and take a look. What happens? This decimal is going to go on and on and on and on, and it's not going to stop. Now, in a calculator, though, it is going to stop just because I can't keep going. The screen runs out, so it does stop there, but it's it keeps going on and on and on. So, and we also know that there's not a whole number times a whole number that is going to make 7, and so this is going to be irrational. All right, square root of 16. Well, let's try that one. And the square root. Square root of 16 is 4. 4 is a whole number. We also know that 4 times 4 is equal to 16, so this is going to be a rational number. 8/9. Any number that can be written as a fraction or dividing one integer by the next other integer, it's like 8 divided by 9, it's going to be rational. Okay? And this one here, and I'm sorry, I have one more to add. Okay. This one right here, because it's got this repeating, keeps going on. If we don't see any of these digits that are repeating themselves, it's not going 7, 8, 7, 8, 7, 8. Therefore, we know that this is going to be an irrational number because what it's doing is it just says that it's going to keep going on and on and on, and it's not going to repeat itself. So this one's going to be irrational. And our one right here, well, any integer that can be divided by another is going to be a rational number. So this one's going to be rational because can I take 6 all over 8? Isn't that the same thing as this right here? And I'm sorry, I do have one more. I promise this is my last one. Number 9. Let's say I've got 6.432 with a line over it like that. Okay, this is also a repeating decimal. What this means is it's going to go 6.432, 432, 432, and it's going to keep going on and on and on like that. The number to repeat itself does not always have to be the same number like you have up here with 2.333 and so forth. Okay, and so this right here, this is going to be a rational number. Okay. So keeping in mind that the irrational numbers are going to be those decimals that are created, and the decimals will go on and on and on and on, and they're not repeating themselves. All right, that's it.